This is the second part of probability. We'll start with random variables here. What is a random variable? A random variable denotes a particular type of outcome of an experiment. Numbers are assigned for every random variables. So every random variable x, it's always denoted by x or y or z with capital letters. So numbers are actually assigned for every random variable denote the number of times the particular outcome occurs. Let's consider tossing two coins. Okay, the sample space would be HH, HT, TH, and TT. Okay, T denotes tail and H denotes head. Okay, if I consider x to be the random variable, I'm using the abbreviation RV for random variable. If x denotes the number of tails, okay, then how do you write what is x? So x values can be 0, which means no tail, and which gives you just h option. And if x is equal to 1, x can take the value of 1, which means one tail, right? And this can have two outcomes, th and ht. I can assign value as 2 for x, which means two tails, and the outcome would be tt, only one outcome, tt. I cannot have x is equal to 3 because there are no three tails possible in this case. Okay, this is x is equal to 0. As you have seen, x is the random variable, and we have assigned numbers to them, and each number denotes the number of times the particular experiment or outcome occurs. Number of times the tail occurs. X is equal to 0, 0 number of tails. X is equal to 1, 1 tail, and x is equal to 2, 2 tails. Okay, that is how the random variable is being interpreted. And always random variables are with capital letters. Now we can find the probability of each. What is probability of x being equal to 0? Which means that the probability of getting no tails. Okay, that is easier. Number of outcomes for x is equal to 0 divided by the total number of sample space. Okay, number of elements of sample space, and here sample space has 4, and for x is equal to 0 your set has only 1, therefore 1 over 4 would be p of x is equal to 0, probability of x is equal to 0. I can also find what is probability of x is equal to 1. As we saw, there are two elements in the set, therefore this would be 2 over 4. I'm going to retain this as 2 over 4. I'm not going to simplify this now. X is equal to 2, and I have tt for x is equal to 2, so this would be 1 over 2. So I have found the probability for each values of the random variable here. You should have noticed one at this point. If I do this to all the three probabilities that I have made, you can easily see that you are going to get something very important, which is plus 1 over 4, which is equal to 1. So always the total probability of a random variable, say x1, x2, x3, x4, where I ranges from 1 to n, is always equal to 1. Okay, p of x is equal to 0 plus p of x is equal to 1 equal to 2 equal to 3 equal to n, whatever it is. So up to whatever number you are taking according to the question asked, the total probability is always equal to 1. This is a very important result. Also, another important result is very obvious because it is probability. This lies in between 0 and 1. So it's always a fraction, sometimes 0 and sometimes 1. All these probabilities are known as probability distribution, and you can represent this in three different forms. One is in table form, the other one graphical form, and the third is function form. Okay, there are three ways of representing a probability distribution. So in table form, what you do is first you make a table with x in the first row and the probabilities in the second row for each x. So the x values that in this question, the x values can be 0, 1 and 2, and the corresponding probabilities that just we now found them as 1 over 4, 2 over 4 and 1 over 4. You can actually write this as half. It's not a mistake, but I'm just retaining it so that the denominators are the same. Okay, this is the tabular representative of this particular question. Okay, and graphical representation, you need to draw the grid as we did for lattice diagram, and it's not the whole grid. You just write the x values on this horizontal line and the probabilities values on the vertical axis, say like this. You can, according to your values in the table, you can do this, and you can just draw 0 corresponds to 1 over 4, 1 corresponds to 2 over 4, which is half, and then you make a big dot and draw dotted line. This is graphical representation. So how do you do functional representation? You could have noticed that when x is equal to x small x is equal to 0, the value for p of x is equal to x is 1/4, right? When x is equal to 1, it is 2/4. I can write this as 2 times 1/4. And when x is equal to 2, this was 1 times 1/4 again. So if you can see what is in this, this is 1 times 1/4. So these values, which are 1, 2 and 1, would correspond to 2C0, 2C1 and 2C2. So you can actually write this p of x is equal to x in this case as 2cx times 1 over 4, where x takes the values 0, 1, 2. So this is representing this particular probability distribution in function form. This is quite easy to identify. Identifying this would have been easier for you. Sometimes this function would be given directly in the question and you need to find p of x for all x values. P of x is equal to 1, p of x is equal to 2 and so on. So that would be easier. Most of the questions would be given in the function form so that you can find their corresponding probabilities and continue with the question. Okay, if in general a question is given, you can easily make a tabular representation of the probability distribution. So that is for probability distribution. You have three ways of representing a probability distribution, and this probability is called discrete random variable probability with discrete random variable. The word discrete comes from the values that x can take. As you can see, the x takes discrete values 0, 1, 2, nothing in between them. So the x values are generally positive integers, or you can even write like this. When the x values that are assigned to the capital X is positive integers, then you have discrete random variable. So that's what we have been doing all this time. Type of distribution would be opposite to discrete is continuous, and we'll be dealing with this sooner now. Continuous random variable and continuous distribution. Here the values of x is any real number. For example, if you take the heights of a plant, okay, if you are making this as an experiment of measuring the heights at different points of or different time, you can have the values of plant height of the plant to be 1 centimeter, 1.1 centimeter, 1.3 centimeter, 2.4 centimeter, etc. Right? They are not just integers, they can be any real number. So in continuous random variable cases, you will be having the x values not mentioning as to be equal to something, but it is like it is in between two values. Okay, so you'll be finding the probability of the random variable between 2 points, which means it's between the interval a comma b. Okay, either this closed or open. We'll be discussing all these things soon. Okay, let's continue with discrete for some more time. Discrete random variable, and we'll come to continuous random variable a little later. Constructing the probability distribution table. How do you do that in different situation? Constructing probability distribution table. There are different ways that the question could be framed. If the question contains something like, if it is in the form of function, as we just did, nc 2c0 2cx. So for example, you have this as your question. If probability is given in the function, in some function form, and it is given like x takes the value 0 1 2 3, then it's simple. You just make the table with x, and p of x is equal to x, substitute the values of x of as 0 1 2 and 3, and substitute it in this formula, and find the corresponding p of x values, and this gives you the table of probability distribution. Okay. And then the next way that a question could be given is something very simple like tossing a coin, as we did now. So for questions like tossing a coin, rolling a die, picking up some marbles from the box, all these things, you know how to find the probability of each event. So with that knowledge, you can find the probability of each event, and you can do what we just did a few minutes before. As a third case, let's consider this example. As a third case, let's consider this example. Okay, in this example, you have you are given the probability of certain events, that is Kirsty being successful is 0.8 and Bridget being successful is 0.75. So some parts of the probability would be given, that is probability of some outcomes would be given, and you need to find the whole table for probability distribution. Now what is x? X is a random variable which denotes the number of success. Okay, so if x denotes the number of success of each of the individual friends, then it could be like, let me use k for Kirsty and b for Bridget. So what happens here is, if x is equal to 0, that means both of them have failed, no success. So if x is equal to 1, at least not at least, one of them have succeeded, that is either kb or bk. Okay, either k b dash, let me use b dash, or b k dash. Dash means it's failure. Okay, here I can use k dash b dash, that both of them have failed. If x is equal to 2, which means both of them have succeeded, which means k b. Okay, now let me draw the tree diagram. It's easier in that way. This is for Kirstine and this is for Bridget. Each of them have two options, which is success and failure. Here it is success and failure for Bridget. Okay, now it's given that Kirsty's success's probability has 0.8 and Bridget's success is 0.75. So I can fill up the rest of the tree diagram. So this is how we fill it up, because the total should be equal to 1. Each branch should give you total as 1, each set of branches. Okay, now we need to find k dash b dash. For k dash b dash, you need to go along this way. So for p of x is equal to 0, we have k dash b dash, which is 0.2 times 0.25, which is 0.05. For kb dash plus bk dash, because this or that, which means plus, so the kb dash is here. For p of x is equal to 1, kb dash would be 0.8 times 0.25, and this plus k dash b, which is here, which would be 0.2 times 0.75, and you can easily see that this is equal to 0.35. For x is equal to 2, it is kb, both are successful, which is 0.8 times 0.75, and which gives you 0.6. As you can see, this totals up to 1, which is very important. If it doesn't, then there is some mistake in some part of your answers. So this adds up to 1. So this is the both are successful You have already done. When both are successful, it's equal to 0.6, and this is the probability distribution. If you want to write it in a table, you can write this as x0, 1, 2, and p of x is equal to x as 0.05, 0.35, and 0.6, and make a table out of this. Okay, this is the table for probability distribution. The second part of B is if one is successful, it is Kirsty. So what it means is either one of them is successful, which means it is KB or K dash B. Given this, it is K is successful. This is the probability that you are supposed to be finding. Probability of K being success, given that KB dash plus K dash B, one of them is successful. So it's easy. P of x is equal to K intersection KB dash K dash B divided by P of x is equal to KB dash plus B of K dash B. We know this conditional probability, K intersection KB dash plus K dash B. So what does this mean? If you go back, it's like it's 0. K intersection KB dash and K dash B would be, with this K, you can do this KB dash is what you get. Okay, you cannot get K dash B. So K intersection KB dash would be P of K B dash divided by 0.35. For this we have already done. KB dash would be 0.8 times 0.25. Therefore this is 0.8 times 0.25 divided by 0.35. Okay, the value would be 0.2 divided by 0.35. Now let's do continuous random variable. Okay, so few minutes back I was telling you what is the difference between discrete and continuous, and the example I gave you was the height of the plants, where you have all real numbers as the value for x. Okay, so discrete would be something like, if I have in discrete like this, then in discrete it would be P of x is equal to 2 plus P of x is equal to 3 plus P of x is equal to 4. You can see that the numbers in between the integers will not be considered in discrete random variable. While in continuous random variable, if I say 2 less than or equal to x less than or equal to 5, this means all the numbers in the interval 2, 5. That is the value that x can take. So x belongs to this closed interval 2, 5. For example, you can have this f of x. Usually it is all continuous random variables are denoted with a functional notation f of x. F of x could be equal to k 2 minus x the whole square, 0 less than x less than or equal to 2, or 0 otherwise. What does this mean? This means that the function, the probability is defined within the interval 0 to 2, and all the other cases the probability is 0. Okay, so the probability is defined by a function. That means this function itself is the probability. You don't need to find the probability again. For, say for example, you should not be doing something like this. This is not the case. The function, given function itself, is probability of x at a particular value. Okay, at x it is k times 2 minus x the whole square between this range. The function, usually for continuous random variable, the function is defined for all values between minus infinity to infinity, all real numbers between minus infinity and infinity. So in this case it is defined for all the values of x from minus infinity to infinity, but it's equal to 0 at all other points except 0 to 2. That is the meaning of this question. So this is the example that we have taken, and I told you this itself is the probability. So this gives you the probability distribution. If I find the values for x between 0 and 2, this actually gives me the probability distribution. And we don't usually call this as probability distribution. We call this as continuous probability density function. Continuous probability density function, which in short is written as CPDF. This you must have seen it in your calculator. CPDF is continuous probability density function, otherwise called continuous probability distribution. So you cannot find P of x is equal to x here. Okay, I'll tell you why very soon. You'll be understanding why we cannot say find x is equal to 2. You can't find P of x is equal to 1. There is no value for this. We'll soon see what it is. What is the total probability? Now f of x, we have already seen that this f of x has been defined for all the values, all the real values from negative infinity to infinity, which means that the total sum is equal to 1. The sum here is integration because it's continuous. For discrete, we use sigma notation because sigma takes the value in discrete terms. But when it comes to continuous values for x, we go switch on to integration to find the sum. So this is a particular property for continuous density function. The same thing we applied here, sigma p of x is equal to xi for I ranging from 1 to n equal to 1. This is being now replaced with integration simple from minus infinity to infinity. This is true for any f of x given. Okay, any continuous random variable given. Now in this case we don't have values for other places other than 0 and 2. Okay, in between 0 and 2. So this can be changed to f of x dx is equal to 1 from 0 to 2. So you don't need to consider the other areas of real numbers. It's just 0 to 2. With this you can write it as 0 to 2 k x minus 2 the whole square dx is equal to 1, and you can actually find the value of k. Okay, the value of k would be, in this case, it's 3 over 8. If you find the integration, and I'm not going to do that here, if you find the integration of this, and you can find the value of k to be equal to 3 over 8. Also, you should have noticed that f of x is always greater than 0 because it's a probability. It cannot be negative for all x values in real numbers. Okay, this is another property of the probability density function. From this integral notation, if I write integral of f of x dx, this means I'm finding the probability of the random variable x between the range a and b. Okay, this is the meaning of the integral symbol. A to b f of x dx means probability of the random variable x between a and b. Okay, a and b could be any real number, and you get all the you consider all the real numbers in between them. If in the same question I ask you to find the probability of x between the values like this 0.5 and 1, then you are supposed to just integrate it from 0.5 to 1 k times x minus, you can substitute the k value here and find the integral, and you can say what it is. Now this is what you are supposed to do for continuous random variables. If in case I have something like conditional probability here, okay, what do you do here? So this is like, if you use your conditional probability definition, this is p of x greater than 1 intersection p of x greater than 0.5 and divided by p of x greater than 0.5, right? It's intersection of a and b divided by x is equal to a. There is no equal to sign here. And p of x, what about the numerator? If you see this, if this is 0, this is 0.5, and this is 1, x greater than 1 would be from here to here. X greater than 0.5 would be here to here. So the common part is from 1. So this put together would be x greater than 1 divided by x greater than 0.5. Probably you note that I'm writing the p of in every case. There is no meaning without that letter p there. So greater than 1 is 1 to 1 to 2. Here there is no infinity because the function itself is defined only up to 2. So 1 to 2 f of x dx. In this case, in the question that we have been dealing with, 0.5 to 2 f of x dx. So according to the question, this upper limit changes, and according to whatever the numbers have been asked here, the lower limit changes, and you can integrate them and find the values. Okay, now we can slightly understand what I said about I cannot have a value as p of x is equal to a for continuous probability density functions. Why? If I consider p of x is equal to a, according to my definition, it should be integral a to a f of x dx. which would be always be equal to 0. So I mean, considering x is equal to a for finding the probability is always equal to 0. It's always within an interval that the probability exists. And what about the difference between writing this and this? Since at x is equal to a, it's going to be 0. So whether I use the equal to sign or not is not going to be of much difference. So it's the same if you write like this. All these four are going to be giving you the same values: less than b, x less than b. So either you whether you put the equal to sign or not in between the range of the interval, it's not going to make any difference in the final value, because equal to the point would be 0. So we have done all the basics about discrete random variable and continuous random variable, and we'll next be finding the mean, median, and other central tendencies for both discrete and continuous random variables and continuous distribution functions. Okay, bye bye.